Hi, Hari, Divya, and Naveen. How are you doing? Shall we wait for others to join? Are you guys here? I'll share my screen. Okay, only host has permission. Okay, Shri Kruti, you are there. All right. Ashwin. So, are you guys solving? Are you guys able to solve problems from permutations? Anyone? Hari, how about you? Are you guys here? Are you guys able to listen me? Am I audible to you guys?
Yes, sir.
Okay, somebody finally replied. Thank you. Okay. Shri, who replied? Shri Kruti replied, right? It was you.
Sir, Divya, sir.
Divya. Okay. Divya, are you able to solve problems from permutations and combinations?
Yes, sir.
Okay. So, are you finding any difficulty? Have you tried solving problems?
Yes, sir, I did.
So, were you able to solve?
Yes, sir.
Okay. See, mostly we will be solving problems based on NCRT, and as you said that that circular permutation isn't there, right? But anyway, you will be able to solve problems from that also, right? Okay. So what we'll do till now we have done so far we have done permutations, right? So I'm sharing my screen. Hopefully you are able to see my screen. Okay. Okay. So we'll be studying combinations. Okay. Before that, let's solve a few problems based on permutation. Okay, circular permutation. I want you to solve some problems. So the problem says, in how many ways can 24-person be seated on a round table? Okay. In how many ways can 24-persons be seated around a table if there is 13 seats? If there are, how many? 13 seats. Yeah. There are 13 seats and 24 people are there, right? So how many ways they can sit? Remember circular permutation we did yesterday? We solved some of the problems based on it. Okay, before you solve this problem, just try this one. Try this problem, the second one first. Okay, find the number of ways in which 12 different beads can be arranged to form a necklace. Okay, find out. See, when we are talking about necklace, that means it's a closed loop, right? It is a closed loop when we are talking about a necklace. isn't it? Yes or no? Hari, Ashwin, it's a closed loop when we are talking about necklace, right? So there are 12 beads from which we will use. So what we will do, we will fix one. If you fix one, now you can arrange all 11. In how many ways you can arrange? So 12 minus 1, that is 11, is 11 factorial ways. You can arrange these beads, right? Yes? Anyone, please reply.
Yes, sir.
Okay. So now in case of necklace, you can either, you go clockwise or anti-clockwise, it doesn't matter. You can go either this side or you go using this direction. It doesn't matter which direction you go. You will, you can always arrange in any direction. It doesn't matter. Okay, so the required arrangement, so required number of ways are 11 factorial by 2, because you can go either clockwise or counterclockwise. Both direction you can go, and it will not make a difference in case of beads. Okay, now try this one. How many ways can 24 persons be seated around a table? Okay, around the table, if there are 13 seats. There are total 13 seats. Let's say something like this. So this is a round table and there are 13 seats. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, let's say 13. Okay, so 13 seats are here. And there are total of 24 persons. 24 people are there. And they need to sit in 13 seats. How they can sit?
Sir,
Yeah.
sir, in the previous question, why are we dividing it by 2? Sir?
Why are we dividing it by 2? See, in case of necklace, I think, did I mention it yesterday or not? Beads and flowers. Did I mention yesterday only we did circular permutation, right?
Yes, sir.
Just a minute. I'm sorry. Okay, see, either, okay. Suppose, let's say you have arranged A, B, C, D, and E. Excuse me. So these are the 5 elements that you need to arrange. Okay, either you go clockwise direction. Okay, you fix, suppose you have fixed A. If you fix this point A and you are going in, sorry, counterclockwise direction, this is counterclockwise direction. So the arrangement is A, B, C, D, E. Now let's do it again. If this is A, again you arrange like this: B, C, D, E. If you are going it in clockwise, counterclockwise direction, it is a different arrangement, right? A, E, D, C, B. But if you go in this clockwise direction, so the arrangement is same, right? These two are same arrangement, right? Isn't it? Isn't it? If you are going in clockwise direction here, you see, if you are going in this direction, and here you are going in this direction, this is counterclockwise direction, and here you are going in clockwise direction, right? Yes, Divya?
Yes, sir. Yes, sir.
Okay, so you see these arrangement, both the arrangement are same. After A, B will come, after B, C, C, after C, D. So similarly, all the arrangement, whatever arrangement, total arrangement possible are 5. So 5 minus 1, 4 factorial it is total. If this are, if we are only going in one, we are counting in one direction. But in case of necklace, this, your beads you can place either in the left side or you can place in the right side. Any side you can place it. So that means these two arrangement will be same. So you will divide it by 2. That's it. If you divide it by 2, you will get distinct, distinct arrangements you will get. Otherwise, the arrangement will remain same. Okay.
Yes, sir.
You got it or not? Means because the clockwise and counterclockwise, these two are different arrangement, by the way. One is going clockwise and one is going counterclockwise. But in case of bits, you can put like, let's say this is a blue color, this you are putting a red color bead here. Again, so if you can put a red color bead here also, it doesn't matter which side you are going. So that's why to find a distinct number of necklace, distinct distinct necklace, you can say. It's different types of necklace. So that will be how much? That will be n minus 1 factorial upon 2, because n minus 1 factorial is the total. N is the total number of beads. You are fixing one bead, so you are subtracting 1. Now all other beads can be arranged in n minus 1 factorial ways. But if you go clockwise and if you go counterclockwise, that will remain same. So you divide it by 2 to get distinct necklaces. Okay. Now come back to this problem. In how many ways can 24 persons be seated round a table if there are 13 seats? All right. So if there are total of 13 seats are there, right? But you have how many people need to sit there? 24 people need to sit there, right? Total 24 people are there and there are 13 seats, right? So here, yeah, so tell me how you will do it. Anyone please tell me how you are going to do it. No? See, in this seat, just fix one seat. In one seat, how many people can sit? 24. Either of the 24 people can sit here, right? Now you fix that. Now either of the 24 have already somebody has occupied that place. Now in this one, in the second one, how many can sit? 23. Here, how many can sit? 22. Right? Yes or no?
Yes, sir.
Yeah. So 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12. So 12, there means 12. And this, so already this position has been filled. Because you have to fix at least one in circular permutation. So what do you exactly need to find out? So 12, so you just multiply 24 into 23 into 22 into till 12. That's it. That's what your circular permutation. Or another way of writing this is 24p13 divided by total of 13 minus 1. So total seats are 13. So yes, divided by 13. So another way of writing is this. I won't recommend writing like this because the meaning has to be very clear. So I think this will help you. This has got a clear meaning. 24 to 12, right? It's like a linear permutation only. So this was all about circular permutation, and we were solving questions based on combinations. So combinations, there are few rules of combinations that what we have studied, and yesterday we saw some of the rules of combinations, right? What rules we saw yesterday? That NPR is equal to R factorial into NCR. This is the first theorem that we proved yesterday. Yes.
Yes, sir.
So this theorem I have explained also using example, right? I think that should be clear to you, isn't it?
Yes,
Yeah?
sir.
Okay. Another theorem is just, you can prove it yourself. Okay, just prove it. NCR, try it yourself, plus and just find out NCR minus 1. How you will write NCR minus 1? Just write it. How you will write NCR minus 1? We know we can write NCR is equal to n factorial upon R factorial n minus R factorial, right? That's how we write. combination, isn't it?
Yes, sir.
Okay, so since we know this, let's say this is a general term. How can we write NCR minus 1? Just instead of R, you will substitute R minus 1. So this will be equal to n factorial upon R minus 1 factorial and bracket n minus R minus 1 factorial. Okay, so this will be equal to n factorial divided by R minus 1 factorial. And this will be n minus R plus 1 factorial. Is this correct? Is this correct or not?
Yes, sir.
Okay, so let's say this is equation number 1. Let's say this is equation number 1 and this is equation number 2. Add equation number 1 and 2. This is NCR minus 1. So add 1 and 2. Add 1 and 2. So find out NCR plus NCR minus 1 will be equal to what? Just add these two. So this will be n factorial upon R factorial n minus R factorial plus n factorial divided by R minus 1 factorial n minus R plus 1 factorial. Find out how we can write this. Or shall I write this? Prove that NCR plus NCR minus 1 is equal to n plus 1 CR. Prove this. Just add these two. Things that you can take common, just do that. See, if the first target must be, you have to find a common denominator. You already have the common numerator, right? Numerator n factorial is already common in both, right? So n factorial. So in the denominator, what else we can find common?
R.
Okay, R. See, here you have R minus 1, right? Now here you see, here you have R minus 1, you have R factorial. Here you have R minus 1 factorial. Can we write this R factorial in terms of R minus 1 factorial? So R factorial, we can write R multiplied by R minus 1 factorial. Yes. And this will be n minus R factorial plus this to n factorial divided by R minus 1 factorial into n minus R plus 1 into n minus R factorial. Can we write like this? See, we are writing in this term, we are trying to write this in this form and this in this form. Sorry, this in this form and this in this form we are trying to write. See this, if you subtract 1 here, you will get this factorial, right? That means n minus R plus 1, you can factorial, you can write n minus R plus 1 multiplied by n minus R factorial. So that's what I have substituted it here, right? So again, we can write this as n factorial. Now see, here in the numerator, n factorial is common, R minus 1 factorial is common, and n minus R factorial is also common. See, so these things are common. So let's take out common things outside. So n factorial whole divided by R minus 1 factorial is common, n minus R factorial is also common. So in the first term, what is left? In the first term only we have 1 upon R plus in the second term we have 1 upon n minus R plus 1 common, right? That's what is remaining, isn't it? Where is it? So this term and this term is not present. So all other terms are common. See, this term and this term is common in both. So that's what we have taken it out. Now you just add these two. What you will get here? If you add, what you will get? N factorial upon R minus 1 factorial, n minus R factorial And if you add this first, you have to take LCM. So R multiplied by n minus R plus 1. In the numerator, what you have? N minus R plus 1 plus R. This R will get cancelled, right? So you can write this as n factorial multiplied by n plus 1. What? Right? The whole divided by, this is your R factorial. No, this is R multiplied by R minus 1 factorial and n minus R plus 1 multiplied by n minus R factorial. So since we have written all term, I'm writing this term and this term together, this term and this term together. Okay. Why are we writing? Because so that we can write this in terms of factorial. Now, can we write these two? We can combine and we can write n plus 1 factorial. Right? N plus 1 factorial whole divided by, we can combine these two and we can write R factorial. And again we can combine the last two terms, that we can write n plus 1 minus R factorial. What is this? This is your, now since the last what we have got, n plus 1 factorial whole divided by R factorial, n plus 1 minus R factorial. This is we have got NCR plus NCR minus 1. This is what we have got. And this we can write in terms of factorial as n plus 1 CR. Okay. So therefore we have proved NCR plus NCR minus 1 is equal to n plus 1 CR. Okay. Fine. So solve a problem based on this. If NC9, this is your NCRT problem, solve example. NC8, if NC9 is equal to NC8, find NC17. How you will find it? How you will proceed for this? See, already you are given NC9. NC9 is equal to NC8, right? So just write in terms of factorial. We need to find the value of n. So n factorial divided by 9 factorial, n minus 9 factorial. That is equal to n factorial divided by n minus 8 factorial into 8 factorial, right? Here we can cancel these two. Cancel means the division will be equal to 1. And here we can write, what we can write here? Anyone? See, this we can write 1 upon 9 into 8 factorial, isn't it? This we can write n minus 9 into n minus 8 factorial. This will be equal to 1 upon n minus 8 factorial into 8 factorial, isn't it? Yes.
Yes, sir.
So what we can write here? So n minus 9 plus, okay, so something is wrong here. This is not what we can write. Sorry, my mistake. This will be equal to, this is n minus 8 into n minus 9 factorial. We subtract, no, we are not supposed to add. I'm really sorry. So add 8 factorial will get cancelled. N minus 9 factorial, n minus 9 factorial you can cancel. So here it is 1 upon 9, that will be equal to 1 upon n minus 8. That's what is remaining. So from here, what we'll get? The value of n is equal to 17, right? So NC17 is equal to 17C17, which is equal to 1, right? Okay.
Yes, sir.
Okay. So yeah, this is an easy problem. Just your example problem. All right. So all of you just try to solve this problem. Determine n, find n is equal to, Find the value of n if number 1, 2nc3, the ratio of 2nc3 to nc3 is 11:1. Find the value of n. Find it. This is your exercise problem, exercise 7.4, question number 2. Exercise 7.4, question number 2, second part. Just write in terms of factorials, that's all. You will get it. Done? How many of you solved? Shri Kruti? Nidhi, are you there online? Yeah, Kruti, you solved it? What's the value of n? Srinidhi, Divya, Shreya has not joined. Abhinav. Okay. Abhinav, what's the value?
Sir, doing so, 1 second.
Dude, with this long, you should not take just to solve these type of problems. Right, in terms of factorial, that's just 2n factorial divided by what? 3 factorial, 2n minus 3 factorial, whole divided by ratio it is saying, right? So n factorial divided by 3 factorial to n minus 3 factorial. That's what the problem is equal to 11. That's what is given. Now write in terms of multiplication. So we can write 2n factorial divided by 3 factorial 2n minus 3 factorial multiplied by 3 factorial n minus 3 factorial whole divided by n factorial. Can we write like this is equal to 11? Yes. So directly you can just 3 factorial. The ratio of this 3 factorial and 3 factorial will be equal to what? 1. So let's just cancel it. Okay. Now what you will do? Now it is important what you will do here. Now what you will do? After this, what you will do with 2n factorial or 2n minus 3 factorial? No idea? See this.
Sir, we can expand the factorial. 2n
Yeah.
into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial.
Yes, exactly. So this 2n factorial, just I'll give you a hint. Just say this 2n factorial, you can write 2n minus 2n minus 1, 2n minus 2, 2n minus 3 factorial. Can you write like this? Yeah, now here you have n factorial or n minus 3 factorial. See, always try to see which is the closest term is available in the expression, in the equation. Okay. See, if the closest term is n minus 3. So try to write n factorial in terms of n minus 3 factorial. Here we are trying to write 2n factorial in terms of 2n minus 3 factorial. So n factorial you can write n into n minus 1 into n minus 2 into n minus 3 factorial. Do that. Done. Okay, I'll do it. I'll try to do it here itself. So you can write 2n into 2n minus 1, 2n minus 2, 2n minus, okay, I'll have to go to next page. I'm sorry. Not possible here. 2n into 2, you just subtract 1, right? When you are writing factorial, that's what we know, how to write factorial. 3 factorial. And why we are writing till 2n minus 3 factorial? Because in the denominator, we have 2n minus 3 factorial. Okay, that's why we are writing it, so that we can cancel it out, so that we can eliminate these terms. So this will be equal to n minus 3 factorial. Now in the numerator, you have n minus 3 factorial, and in the denominator, you have n factorial. So you can write n minus 1, n minus 2, n minus 3 factorial, right? So now, see, this and this you can cancel. This and this term are common, so the ratio will be equal to 1. Okay, sorry, I think this is multiplied, right? I'm sorry, multiplied. This is equal to 11. Okay. Now this again you can write what do we have? 2n.
N is equal to 6.
Now what we can do? Yeah, now what we should do? We can also cancel out this one n, right? Is it or not? This is just n. This is not factorial, so we can cancel it. This is not, see, if 2n factorial divided by n factorial, please do not cancel these two, because the meaning is different. This is, and see, the meaning is different here. If this, you cannot cancel like that. Okay, not like this. If it is 2 into n factorial divided by n factorial, then you can cancel these two. Here it's written 2n factorial, and it is just 2n, not factorial. Here you see this is not factorial, this is just 2n. So 2n divided by n you can cancel. That means the ratio will n by n will be equal to 1, right? That's why we have cancelled. So what is remaining? 2 multiplied by 2n minus 1, 2n minus 2, right? Divided by n minus 1, n minus 2. That's what we have. This is equal to 11. That's what we have got. Okay, please do not cancel out 2n. Sometime it is written 2n factorial. The meaning is 2n factorial. Okay, divided by n factorial. Please do not cancel like this. Please do not do that. If it is 2 multiplied by n factorial divided by n factorial, then you can cancel these n factorial, n factorial. Okay. Yeah. Similarly, as in trigonometry, that's what you have done. No, sine theta divided by what? Like sine 2 theta divided by what? Sine theta. You guys, some of you have cancelled like that. Theta will get cancelled. Please don't do these things. I've explained this in class. Please do not do that. Now, how you can solve this? We have solved this far. Now we need to find the value of n. How we can do this? Anybody? Anybody is having idea? Any idea at all? See here,
So
2
we
is.
can take two common.
Yeah, yes. Tell me.
We can take 2 common in 2n minus 2, and we can multiply it with that 2. Then
Yes.
n minus 1 and n minus 1 get cancelled.
Exactly. So 2. Now in this term, we can take 2 common. See, 2n minus 2 it is, right? So we can take 2 common. We are taking 2 common, so it will become n minus 1. And we already have term 2n minus 1 whole divided by n minus 1, n minus 2, right, is equal to 11. Now this n minus 1 and this n minus 1 you can cancel out, right? So this you can write 4 times of 2n minus 1 divided by n minus 2 is equal to 11. See, you have got this term. Till so far we have cancelled. Now what we should do? You can just cross multiply it, right? You just cross multiply. So here you can write 8n minus 4. 8n minus 4 is equal to 11n minus 22. Fine. Anybody is having doubt here? Huh? So 11n minus 8n will be equal to, okay, so what I'm doing, I'm just taking it this side, okay, and writing fresh. And this will be 22 minus 4. I'm taking 22 this side. All right. Or something wrong I have done. Wait. Let's write it properly. So 22 minus 4 will be equal to 11n minus 8n. Now this is fine. So 22 minus 4 is how much? 18, right? And this will be equal to how much? 3n. So n will be equal to how much? 18 by 3, that is equal to 6. Understood? This is just fighting with equations. Okay, that's it, nothing else. You just have to make sure that the next line that you are writing, every next line that you are writing is following the above line. Okay, it's following this. This can be written in this term, this can be written in this term, this can be written in this term. That's it. You just need to take care of. That's it. You have studied that, right? Bracket of divide, multiplication, addition, and subtraction. Right? So you just need to take care of this and you will be okay. These are just equations. Now let's solve some of the problems based on this combinations. Okay, word problem. Let's solve some of the word problems. What do you mean by combinations? Can anyone find this value? Okay, let's leave it. Okay, let's solve from NCERT. So find a committee of 3 persons. Your exercise 7.4. Exercise 7.4. Question number 8. Just try that. Question number 8. See, in how many ways one can select? I think it's a different question. In how many ways one can select a cricket team of 11? This is question number 7, right? Question number 8. A bag contains 5 black and 6 red balls. So there is a bag which contains what? 5 black balls and 6 red ball. Okay. Determine the number of ways in which 2 black and 3 red balls can be selected. So now what you are doing, you are selecting 3 black balls and 2 black balls. I'm sorry. You have to select 2 black balls and 3 red balls. How can we do that? See, here the order we have studied, we know that order doesn't matter here. In combinations, order doesn't matter. So how many ways we can select it? How many ways we can do it? See, there you can select 2 black balls out of these 5 black balls, right? So there are total of 11 balls, but that doesn't matter. Out of 5 black balls only, you can select 2 balls. And how many? How can you do that? So 2
C2
black.
into 63.
Yeah. So 5C2 ways, right? 5C2 ways you can select these balls. 5. This is you are selecting 2 black balls out of 5 black balls. Okay. So how many ways you can select 3 red balls?
63.
63 ways. Selection of 3 red ball out of 6 red ball. So this is the method. And so total principle, you have to select this and this. See here, this and this. It's not like you have to select black or red. You have to select black and red. Okay, that's the question. That means from fundamental principle of multiplication or fundamental principle of counting, what we can say, these two will be multiplied. So total selection, the way we can select is 5C2 multiplied by 6C3. So this will be your total combinations possible, total possible selection. Okay, so how much will be this?
200.
5C2 will be how much? 5 factorial upon 2 factorial, 3 factorial. So 5 into 4 upon 2, that will be 10. 5 into 4, so 20. Okay, so this will be 200. Right? So there are 200 ways to select 2 black balls out of 5 black balls and 3 black balls out of 3 red balls out of 6 red balls. Now, how is it different from permutation? See, in permutation, order matters. It's like if first you are selecting this black ball, then you are selecting one red ball, like that. That order will matter here. But here, you just need to select 2 balls. It can be any 2 balls. 3 red balls. It can be any 3 red balls. Okay. See, combinations are really important for your probability. Okay. Most of the applications of combination you will find in probability. Like in probability, you will have questions like, so the total selection means if you are taking one ball out of randomly one ball out of this bag. So what is the probability of choosing a red ball? Okay, or what is the probability of choosing a black ball, like that? That can be the questions in probability. Okay, so please be careful when you are solving this combinations. We are already done with permutation. So, okay, go to page number 150. Page number 156. Or let's solve 1 or 2 problems from this exercise itself. Wait. Solve question number 7. Question number 7, please solve. Same exercise, 7.4, question number 7. So the question is, in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? That means there are 5 bowlers and you need at least 4 bowlers. Okay, so you have to select 4 bowlers out of 11, out of only 5 players, out of 5 bowlers, and you have to make a team of 11. How can we do that? See, there are how many total? 17 players. Total there are 17 players. you have to form a team of 11 players, right? That's what the question says. And in 17 players, you have 5 bowlers. Okay. And a team must include 4 bowlers. Okay. That means you have to select 4 bowlers out of these 5 bowlers. How can you select that? Selection of bowlers. How can you select the bowlers?
I see 4 ways.
5C, 4. Yes. So 5C4 is how much? How many ways you can select a bowler? 5C4 is how much? 5 factorial upon 4 factorial into 1 factorial, right? So that will be your 5, isn't it? 5 ways we can select. Okay. Now see, you have now what you will do? Out of 5, you have already selected 4. That means now how many players are remaining? You still need to form a team of 11, right? So 4 you have already selected out of 5. So you are remain with 17 minus 5 players. Okay, these many players are remaining still to be selected, and that is equal to 12, by the way. 12 players still need to select it, and you have already selected 4. So if you have to form a team of 11, that means you still need 11 minus 4, that is equal to how many? How many? 7, no? 7 players. So now you have to select 7 players. 7 players out of 12 players. How can we do that? 12C 7 ways, right? So these are the now this is the bowlers, and these are other players. So this and this together will form a team. And statement is always there. So 5 multiplied by 12C 7 ways, we can select the team. We can form a team of 11. So this is the required combination. So 12C 7 will be how much? 12C 7 will be how much? So this will be equal to 5 multiplied by
178.
12 into 11 into 10 into 9 into 8 into 7 factorial divided by 7 factorial into 5 factorial. So 5 into 4 into 3 into 2 into 1. 7 factorial cancel. 5 into 2 is 10. 3, 3, 9, 4, 2, right? So this 12 into 11 into 6 is how much? 12 into 11 into 6 into 5. So 5, 6, 30. 30 into 2, 12 into 11. So this is 121, 141, so 3. What was the multiplication? Into 5 also you should do. What is the total number? I'm very bad at multiplication. How much is the answer? Arey, I just do not. 12 into 11 is how much?
890.
Okay, and total ways of selecting team will be how much?
The total is 890, sir.
890? No, how can you say 12 into 11 is equal to 132, right? Multiplied by 6. 6 into 5, 30. How much will be this? See this, don't forget this 5, this, and these 2, right? Now do that. How much we are getting? So this will be equal to your 3960. So this is the total number of ways that you can select this team of 11. Understood this question?
Sir,
Yeah. Yes.
sir, this 12C7, That step I can't understand.
Which part? Which part?
Second part, sir. After finding that
Okay.
bowl is.
Okay. Bowlers is clear, right? Till bowlers
sir.
it is clear. Okay. I'll erase. I'll explain again. Okay. See, this is just multiplication and division. So let's. Till bowlers it is clear. So this is clear. So far
Yes,
it is
sir.
clear, no? So far, okay. So far, no problem. Now, see, you have to select a team of 11 players. Total, there has to be 11 players, right? In a team. 11 players has to be there, right? In a team.
Yes, sir.
And total, how many players are there? 17, right? In 17, there are 4 bowlers. Total 5 bowlers are there, right? That means in 17, 12 players, 12 there can be wicket keeper, there can be batsman, there can be other player, plus 5 bowlers, right? Can we write like that? Yes.
Yes, sir.
Okay. So these are bowlers. And out of these bowlers, we only need 4 bowlers. So if we are selecting 4 bowlers, so these many ways we can select 4 bowlers. 5, because there are 5 bowlers and we have to select 4 bowlers. Fine. This is clear?
Yes, sir.
Okay. Now the team must have 11 players, right? Team must have 11 players. Since we have already selected 4 players, so how many more players we need to select? 11 minus 4?
Yes, sir.
Is this clear or not? See, a team has to be formed of 11 players. We have already selected 4 players, right? So how many more players we need to select? 11 minus 4 players, right? That is 7 players. Isn't it? Yes or no?
Yes, sir.
So how many players are not selected yet? 12 are not selected yet. So out of these 12, we need to select how many players? 7 players. Right? Yes or no? See, this together will form a team of 11, isn't it?
Yes, sir.
Okay. So this and this we need to select. So how many ways we can select 7 players out of 12 players? Huh?
12 C, sir.
12C7 and
Yes, sir.
12C7, we found the value. Yeah, tell me. Yes, please tell me. You have some doubt? You are asking something? Divya was asking doubt, right?
Yes, sir.
Okay. So this is equal to how much? 792. Okay. And since we have to select these players and these 4 bowlers, so we have to multiply, fundamental principle of multiplication or fundamental principle of counting. So 792 multiplied by 5, that will be equal to how much? 3960. So these many ways it is possible to select a team of 11. Okay. Is this clear or not? Are you
Yes,
still
sir.
having doubt? Okay,
No, sir.
solve one more problem. If you still have doubt, let's solve one more problem. See, doubts, if you have doubt, it is fine. It's okay to have doubts. Okay. So now solve question number 6. Determine the number. Okay. Solve question number 5. Solve question number 5. See, question number, find the number of ways of selecting 9 balls from 6 red balls, 5. We did that, right? No, we haven't done this. We did this type of problem, so leave it. Leave it. We just did this type of problem. You can do it by yourself. In how many ways can a team of 3 boys and okay, do question number 4. In how many ways a team of 3 boys and 3 girls be selected? So in a team, you need 3 boys and 3 girls. Okay. So this together will form a team. Okay, fine. And how many boys are available to be selected? So 5 boys and 4 girls are there, right? So how many ways can you select 3 boys out of 5 boys, Divya?
Sir, 5C3.
5 C 3 ways you can select boys multiplied by 4C3. These many ways you can select girls
Sir,
out of 4 girls. See, this is your selection of 3 boys out of how many boys? 5 boys. And this is your selection of 3 girls out of 4 girls, right? Is this clear? And see, you have to select 3 boys and 3 girls. That means fundamental of principle of counting, what it says, you have to multiply when there is and statement. Okay. See, if the team comprises of either 3 boys or 3 girls, right? So that time you will just add it. Okay, do one more problem. Okay, question. Okay, let's do one more problem. These are higher standard problem. Let's not do that. Divya, you understood or not? Like previous problem and this problem, these are
Yes,
going to
sir.
work at a really similar problem, right? See, now question number, I think 5 is similar. 5, 4 you can do by yourself, right? Let's do question number 6. Deck of card, we haven't done any problem, right? So determine the number of 5 card combination out of 52 cards in a deck if there is exactly 1 ace in each combination. Yes. Okay. So first we need to understand this deck of card. Okay. How many of you know about deck of cards? Anyone? See, there are total of 52 cards in a deck. Okay. So half of them are black. So 26 black and 26 red. Okay. Out of these, so you have 4 colors in these cards. Okay. So that is 4 colors means, okay. I see, the thing is, I'll explain you about this deck of card in next class. Okay. Tomorrow we'll finish combinations and tomorrow we'll do question based on deck. Meanwhile, if possible, please go and check about deck of cards. So how a deck of card is comprised of. Okay. Can you do that? See, there are
Yes.
13 cards in each suit. Okay. So there are 4 suits. Okay. So in each suit, there are 13 cards. So 2 suits are of red color. 2 suits are of red color and 2 suits are of, 2 suits are of black color and 2 are of red color. Okay. So there will be 13, 13, 13, 13. Okay. One, and in red you have a heart is there in red. I don't know how to draw heart. Never done that. Okay. And okay, I'll explain it more in more details. Okay, I'm having another class right now, so I'm really sorry about that. Okay, so 4 suits are there, and in each suit there are 13 different cards. Okay, there are 13 different cards, and it start from ace. Okay, ace, it's called A. That is 1. The value is 1, and 2, 3, like that till 10. Then you have J, Q, K. Okay, king. K for king, J for jack. I'll explain you. In each suit, it is. Each suit, it has 13 cards. Okay, that means there are 2 red color card, 2 red aces and 2 black aces will be there. So I'll explain you this deck of card in next tomorrow's class, and we will close combinations, permutation and combinations. Okay, thank you so much. Bye. I'll see you.